Hi students, today I am going to deal with the first unit of the subject Analytical and Biomedical Instrumentation. We are going to discuss about the introduction to analytical instrumentation and spectrophotometer. The learning objectives. Upon completion of this presentation, you will be able to understand what is analytical instrumentation, block diagram of analytical instrumentation, and basic blocks of analytical instrumentation, spectroscopy, and types of spectroscopy, and electromagnetic spectrum. Upon completion of this presentation, you will be able to understand what is analytical instrumentation, block diagram of analytical instrumentation, basic blocks of analytical instrumentation, spectroscopy and types of spectroscopy, and electromagnetic spectrum. Analytical instrumentation. Analytical instrumentation is a branch of instrumentation which deals with identification of composition of sample of matter. Suppose you have a sample and you want to identify the components present in that matter. What are the different components that are present in the matter, which can be done by analysis only. And that analysis is carried out by analytical instrumentation. We have various number of analytical instruments which can be employed to obtain qualitative information about the presence or absence of one or more components of the sample. Analytical instruments are also used to obtain quantitative data also. So, I would like to repeat once again, analytical instruments, why we use them? They provide information on the composition of a sample of matter. They provide information on the composition of sample of matter. Analytical instrumentation is very useful in different areas. It can be used in the field of oil refineries. It can be used in process industries. It can be used in food processing industries. It has widespread applications. Many areas we make use of analytical instruments. What are analytical instruments? Analytical instruments are a large class of instruments which are used for analytical applications where analysis is needed. You are going to use these instruments in analysis of chemical industries, in pharmaceutical industries, clinical industries, food processing laboratories, and oil refineries. The instruments help in analyzing materials and establishing the composition. Among the most common, before I go to the most common type of instruments, analytical instruments, I would like to emphasize that the importance of analytical instrumentation is so much that without this you cannot have a proper quality of the product. Like for example, if you take the case of food industry, analytical instrumentation in any industry is to analyze a given sample for assessing its purity. You need to assess the purity of the instrument. During the analysis, various parameters, when the analysis process is going on, you are going to measure various parameters of the given sample for assessing its purity. During the analysis, various parameters and properties of the sample will be checked to ascertain whether the product conforms to the set quality specifications. The analysis can be either qualitative or quantitative. Analysis can be of two types. It can be either qualitative or it can be either quantitative. The analytical instrumentation plays a very vital role in food industry especially. Let us take an example. A food product can be tested for its various nutrients in today's world, compliance to strict quality norms is an absolute must. Hence, every batch of food product that is manufactured or naturally collected must undergo certain quality checks. Any food product which is being manufactured must undergo quality check. Analytical instrumentation has undergone tremendous developments in the past couple of years, and for every type of quality check, a suitable analytical instrument is available today in the market. One has to identify the tests the food product has to undergo and accordingly select the right type of equipment for that. The important tests that are normally carried out in food industry and the equipments that are normally used are different types of analytical instruments that are used in food industry are gas chromatographs, mass spectrometer, then we have high performance liquid chromatographs, we have spectrophotometers, particle size analyzers, which are and among them the most suitable type of instrument that is used for analysis of food products is chromatographic equipment is mostly used to analyze fatty acids, food additives, residual pesticides, aromas and flavor, residual solvents, etc. So their in food industry analytical instruments are very useful for analysis of quality of purity. There are other types of commonly used analytical instruments like spectrophotometers, refractometers, calorimeters, electrochemical instruments, conductivity meters, automatic density meters, then automatic titrators, colony counters, demagnetizers. Then we have other instruments like chromatographic columns. We have the other instruments like colony counters, fiberscopes. Wide variety of equipment is used. Analytical instrumentation field has become more sophisticated nowadays. In the contemporary time, microcontrollers and personal computers have been integrated into analytical equipments to present more accurate findings. For accuracy purpose, we usually use different types of instruments integrated with computers and microcontrollers. Some of these instruments also play a critical role in monitoring and control of environment pollution. Laboratory analytical instruments only from reliable manufacturers, suppliers and exporters get these instruments because the product must be reliable. Coming to the basic block diagram of analytical instrumentation, it comprises this analytical instrumentation. As I told you, it provides information on the composition of a sample of matter. Analytical instrumentation provides information on the composition of sample of matter. They are employed to obtain qualitative and quantitative information about the presence or absence of one or more components of a given sample. So this instrumentation comprises of 4 basic elements. The first one is the chemical information source. The second one is the transducer. The third one is the signal converter or signal conditioner, whatever it may be. And the fourth one is the display system. So the first 2 modules, that is chemical information source and the transducer, they constitute the characteristic module, whereas the last 2 constitute the processing module. They constitute the chemical information source and the transducer together constitute the characteristic module, and the last 2 components, that is the signal conditioner and the display system, constitutes the processing module. So molecules, they possess three types of energy: internal, before going into the types of energies, I would like to describe the blocks of analytical instrumentation. The first one is the chemical information source. The chemical information source generates a set of signals containing necessary information. This necessary information comes from the interaction of stimulus with the sample. When stimulus in the form of either light energy or heat energy or thermal energy, light energy, thermal energy or electrical energy in the form of current or voltage, when it is passed on to the sample, when it penetrates through the sample, or when it, in other words, when it interacts with the sample undergoes some, there exists some change occurs in the sample. So the chemical information source generates a set of signals containing necessary information. The signal may be generated from the sample itself. For example, the yellow radiation emitted by the heated sodium atoms constitute the source of signal in a flame photometer. When we take the case of a flame photometer, it is an example of an analytical instrument where you are going to test a sample. If the sample contains, you are going to burn the sample, you are going to burn the sample in a flame. So when the color of the flame changes, depending upon the color or intensity of the radiation that is being emitted, you can identify the sample. So when the signal, information from the from the sample comes out, that is called chemical information source. When it generates a set of signals containing necessary information, the signal may be generated from the sample itself. For example, the yellow radiation emitted by the heated sodium atoms constitute the source of signal in a flame photometer. The next stage is your transducer. The transducer, as commonly known for everyone and every instrumentation engineer, transducer is a device which converts one form of energy into another form. It may be a non-electrical quantity which may be converted into an electrical quantity. For example, a photocell or a photomultiplier, where it takes light energy and converts into electrical energy. The radiant energy falling on the photocell or photomultiplier gets converted into electrical signal. So transducer is the basic sensor, or it is the most important part of an analytical instrument. So the transducer receives the chemical information from the source, and this information is passed on to the next stage, that is the transducer, where it gets converted into some other form, useful form. So the combination of the chemical information source and the transducer together produces the module called, characteristic module. So the characteristic module comprises of the chemical information source and the transducer. So the next block of your basic block diagram of analytical instrumentation is your signal conditioner. The signal conditioner converts the output of the transducer. The output of the transducer is a very weak signal, so it may not be sufficient enough to drive your output device. So you need to condition your signal. You need to do some manipulation for the signal produced by the transducer. Either it may be amplified or attenuated, or it may be, you will be using several types of methods for conditioning your signal. So the signal conditioner converts the output of the transducer into an electrical quantity which is suitable for operation of the display system. Signal conditioners may vary in complexity, like they may be simple resistance network or impedance matching circuit or device, or a multi-stage amplifier, or any other complex electronic circuitry. They help in increasing the sensitivity of the instrument by the application of amplification of the original signal or its transduced form. So the sensitivity of the instrument is increased. So a signal conditioner converts the output of the transducer into an electrical signal suitable for operation of the display system. So this is the most important stage where your signal is being processed. The next stage is your display system. This display system may be either of the following. It may be either a displacement on a scale, that is an analog mode, or it may be a chart recorder, or it may, you have a stylus, and the stylus moves on a chart and it begins to record, or it may be a CRO, screen of a CRO, or it may be in the numerical form, the digital mode. It may be in the analog mode, like a pointer moving over a calibrated scale, or it may be on a chart recorder. You have a stylus which moves on a paper or on a graph sheet or whatever it may be, or it can be a CRO screen where you can see the you can, just like your TV monitor or a screen, where you can observe the output waveforms or the display or the output of the system, or it can be either a numerical form, in the numerical form, the digital mode. So together the third stage is what? It is the signal conditioning stage, and the display system together forms the processing module. So this is the basic block diagram, which consists of, let's have another view of another diagram representing the analytical instrumentation, blocks of the analytical instrumentation. As shown in the figure, you can observe that a stimulus, which may be a light energy or heat energy or electrical energy in the form of current or voltage, is passed into the sample. The sample will interact with the electromagnetic radiation, with the radiation or with the stimulus, and it gives an information. So the output of the sample the output coming from the sample is the chemical information source. Then what happens? This information is given to the transducer. The transducer converts this information into a useful form. A non-electrical quantity is being converted into an electrical quantity, and that electrical signal, which is not sufficient enough to drive your display system. So this signal is to be processed, and it is being processed by a signal processor, which may be an amplifier or a digitizer. The output of the processor is sent to your readout device, which may be a digital meter or an analog meter, which may be a plotter or a computer screen or a CRT screen, thereby displaying the output that is being measured. So these are the basic blocks of the analytical instrumentation. So spectroscopy. Spectroscopy is the important topic which is to be discussed. Why you need for spectroscopic analysis? What is the meaning of spectroscopy? Spectroscopy is the study of interaction of matter with electromagnetic radiation. As we have seen in the first stage, the chemical information source is the most important stage. So in this stage what is happening? Your radiation is interacting with the matter. It is interacting with the sample. So spectroscopic analysis is very, very important. Many a times it is essential to know the composition and as well as the percentage of the constituents of the substances correctly. You need to know them very precisely. For analyzing any material, for its composition and percentage of constituents, it is necessary to use properties or qualities which are not possessed by other materials or compounds being analyzed at the same time. When you are having two or more components in the same sample, how to differentiate, how to identify them, how to differentiate one element from another? So you have to take certain properties which are not common, which are unique for that specific element. In general, what is happening? The material being measured by the methods which we are going to study, it must be a binary method. It must be binary. The material which we are going to analyze. Even though compound is composed of several components, if only one is affected by the method, then that material is considered to be binary. It may have several components within that, but if only the method which we are analyzing, it measures the property of only a single element, then your process is a binary process. So optical analysis, these spectroscopy is an optical analysis. So optical analysis is finding extensive use which employs different phenomena and a fairly wide portion of the electromagnetic spectrum, which we are going to learn in the further classes. The electromagnetic spectrum is a band of radiation, or the band of radiation which extends from a shorter wavelength to longer wavelength, which we will be dealing in the forthcoming classes. So it is ranging from UV to infrared region. So UV rays have greater sensitivity because of the greater amount of UV energy than the methods employing the IR energies. So different techniques are utilized for analysis. The analysis for to identify a material is different for different elements. It is used for different concentrations. By measuring the absorption throughout a band of frequencies, an absorption pattern can be generated, can be obtained, and by comparing this pattern with the other patterns, you can identify the unknown material also. Then infrared analysis, it can be of two types. We have dispersive and non-dispersive. In the dispersive system, it doesn't employ any optical system. In the non-dispersive system, we use optical methods. So different types of analysis methods are there. So spectroscopy is the study of interaction of matter with electromagnetic spectrum. Interaction of matter with electromagnetic spectrum. So in the spectroscopic analysis, what we do, the atoms of a substance, they are excited. Thereby the configuration is changed. The atoms of a substance are excited. When they are excited, what happens? Their configuration changes and they either absorb or radiate energy at unique frequencies. Therefore, it becomes available for identifying the existence of a particular atom from a substance. You get different types of spectra, emission and absorption spectra for different types of elements. So, spectroscopy is a study of interaction of matter with electromagnetic radiation. It is a branch of science that deals with the study of interaction of electromagnetic radiation with matter. It is an analytical technique which helps to determine the structure of molecules in a sample. So types of spectroscopy. So the first one is the absorption spectroscopy. The study of absorbed radiation by molecules in the form of spectra is called absorption spectroscopy. Like for example, in absorption spectroscopy, what happens? It is based on the principle that when IR, infrared or ultraviolet or X-ray radiation, when it is passed through a sample of unknown material, when this type of radiation is passed to the sample of unknown material, certain frequencies of the radiations are being absorbed. This is determined by separating the radiation into a spectrum. Okay, you're going to separate the radiation into a spectrum and measuring the intensity of the radiation at each frequency. Absorption lines are dark lines on light background on a photographic negative. So what you're going to study? You're going to study the unknown, how you're going to identify the unknown material in a given sample. Certain frequencies of radiations are absorbed by the radiation. When you are passing infrared or ultraviolet or X-ray radiation, when it is passed through the sample unknown material, certain frequencies of the radiations are absorbed. This is determined by separating the radiation into a spectrum and measuring the intensity of the radiation at each frequencies. When we come to the case of examples of absorption spectroscopy are UV, IR, NMR, colorimetry, atomic absorption spectroscopy. Emission spectroscopy. The radiation emitted by the molecules can also be studied to reveal the structure of the molecules. Like for example, you have the unknown substance. That substance is placed in a flame or an arc. When you place the substance in a flame or an arc, this causes emission of radiation, which is the characteristics of each substance. It causes, when it is placed in a flame, it emits a specific radiation. Okay, which is the characteristics of each substance. Now what you have to do, you have to collect that emitted radiation and separate it by the refraction or diffraction and measure the intensity at each frequencies. Then you get a set of emission lines, which are bright lines over dark background on photographic negatives. In that way, you can measure, you can identify the unknown material in the sample. So emission spectroscopy, you are going to take the sample, you are going to burn in a flame on an arc. It causes emission of radiation, which is the characteristic of each substance that is present inside that sample. By collecting the emitted radiation and separating them by the process of either refraction or diffraction, the intensity of the radiation can be measured, and its frequency, at each frequency also it can be measured. So emission lines are dark lines on bright lines on dark background. So this is about. There are other types of spectroscopy also, like infrared spectroscopy, mass spectroscopy, ultraviolet spectroscopy, NMR spectroscopy, that is nuclear magnetic resonance spectroscopy. These are the different types of spectroscopies which we are you will be studying about different types of spectroscopics in detail. Then what is infrared spectroscopy? Infrared spectroscopy measures the bond vibration frequencies in a molecule, and it is used to determine the functional group. Mass spectroscopy fragments the molecules and measures the masses. Infrared spectroscopy measures the bond vibration frequencies in a molecule and it is used to determine the functional group. Mass spectroscopy, what does the mass spectroscopy do? It measures the fragments. You are going to take fragments, the molecules, and measure the masses. Then we have other types of nuclear magnetic resonance spectroscopy, which detects the signals from the hydrogen atoms and can be used to distinguish the different isomers. Then we have ultraviolet spectroscopy, which uses electronic transitions to determine bonding patterns. So these are the different types of spectroscopies which you are going to deal in detail in the forthcoming classes. So coming to the basic classification, as I told you, it is classified into two types. Spectroscopy is classified into two types: atomic spectroscopy and molecular spectroscopy. Atomic spectroscopy is nothing but the study of electromagnetic radiation absorbed and emitted by atoms. Emission, fluorescence and absorption of electromagnetic radiation or ions are the basis of atomic spectroscopy. Emission, fluorescence and absorption of the electromagnetic radiation or ions are the basis of atomic spectroscopy. The study of electromagnetic radiation which is being absorbed and emitted by atoms. The radiation range involved is from visible to UV up to X-rays. Then atomization process converts molecular constituents of the sample into atomic particles, and during this process UV and visible spectra of the atomized species are obtained by emission. As I told you, they are obtained by emission, absorption or fluorescence, which forms the basis of analysis of this analysis technique. Which analysis? Atomic spectroscopy. It is a determination of elemental composition by its electromagnetic or mass spectrum. Electromagnetic or mass spectrum. Molecular spectroscopy. Molecular spectroscopy is the study of absorption of light by molecules. In the gas phase at low pressures, molecules exhibit absorption in narrow lines, which are the characteristics of the molecule. Which are the characteristics of the molecule. Electromagnetic radiation. Coming to the, so what is electromagnetic radiation? It is a type of energy, that is transmitted through space at a speed of approximately 3 into 10 power 10 centimeters per second. This radiation does not require any medium for propagation and can readily travel through vacuum. Electromagnetic radiation may be considered as discrete packet of energy called photons. Electromagnetic radiation may be considered as discrete packet of energy called photons. So, electromagnetic radiation is a type of energy that is, it is a type of energy. Electromagnetic radiation is a type of energy that is transmitted through space at a speed approximately 3 into 10 power 10 centimeters per second. This radiation does not require a medium for propagation and it can readily travel through vacuum. Electromagnetic radiation may be considered as discrete packets of energy called photons. The relationship between energy of the photon and the frequency, is given by E is equal to h nu. So, a beam of radiation may be regarded as electromagnetic radiation. A beam of radiation may be regarded as electromagnetic waveform or the disturbance or photon of energy propagated at a speed of light. A photon originating at a point in space radiates from that point in a spherical way, which may be characterized by electric field vectors and which have periodic maxima perpendicular to the direction of propagation. So, the energy of the photon is given by E is equal to h nu, which is equal to hc by lambda, where c is the velocity of light in vacuum, which is 3 into 10 power 10 centimeters per second. And lambda is the wavelength, and we have h is the Planck's constant, whose value is 6.625 in 10 power minus 29 erg seconds. Nu is the frequency in cycles and E is the energy in ergs. Electromagnetic spectrum. The interaction of matter and radiation takes place throughout the entire electromagnetic spectrum. The name given to a broad range of radiation extending from cosmic rays to, with wavelength as short as 10 power minus 9 nanometers all the way up to radio waves, which have maximum length in excess of 1000 kilometers. So, the basic electromagnetic spectrum is nothing but interaction of matter and radiation takes place throughout this spectrum. It is a band of radiation, in other words, broad range of radiation which extends from cosmic rays to radio waves. So, cosmic rays to radio waves. So, this is the basic figure of electromagnetic spectrum. It is the basic figure of electromagnetic spectrum, where you have the lowest frequency range is radio waves, which have lowest frequency but longer wavelength, and the shortest frequency and shorter wavelength and higher frequencies are gamma rays. Okay, so the order of energy is from radio waves to gamma rays. Okay, different we have the radio waves, microwaves, then we have infrared rays, then we have visible rays, ultraviolet rays, near ultraviolet, vacuum ultraviolet, X-rays and gamma rays. Gamma rays are of shorter wavelength, whereas radio waves are of longer wavelength. The nature of all these, so encompassed within these extremes and moving from the shortest to longest wavelength are: shortest is the gamma rays, then we have the X-rays, then we have far and middle and near ultraviolet rays, then we have the visible light portion of the spectrum, then IR rays, infrared rays they are called, and microwaves. These together form the electromagnetic spectrum. The nature of all these radiations is the same and all move with the speed of light. Okay, they differ only in their frequencies and wavelengths and in the effects which they can produce. Okay, so all these radiation, all these band of frequencies or band of radiations with different wavelengths, all of them have the same nature. All of them move with the speed of light. They differ only in the frequency and wavelength and in the effects which they can produce. Like for example, the chemical and physical effects of various types of radiations are quite different, and their differences can be understood in terms of the differing energies of the photons. The chemical and physical effects are different for different radiations. In radio frequency range, the energy of one photon is very low and the energy transmitted are concerned with reorientation of nuclear spin states of the substances. Okay, so visible lights, then when we come to the case of the visible light, it represents only a very small portion of the electromagnetic spectrum, and it generally covers a range from 380 to 780 nanometers. The ultraviolet region extends from 185 nanometers to visible. Shorter wavelengths lie in the far ultraviolet region, which overlaps the soft X-ray part of the spectrum. Then the infrared region covers wavelength above the visible region. So we have the shortest wavelength is gamma rays, then comes the X-rays, then comes the ultraviolet rays, then comes the visible rays, visible region, then we have the infrared region, then the microwave region and the radio waves. So electromagnetic spectrum is the range of all types of electromagnetic radiation. It is the range of all types of electromagnetic radiation. Radiation is the energy that travels and spreads out as it goes. The visible light that comes from a lamp in your house and the radio waves that come from a radio station are two types of electromagnetic radiation. As we have seen these things we see in our day-to-day life. You see the visible light. It is a part of an electromagnetic spectrum. Then we use the music and radios from a radio station which are being telecasted are the two types of electromagnetic radiation. Other types of electromagnetic radiation that make up the electromagnetic spectrum are microwaves, infrared light, X-rays, ultraviolet rays and gamma rays. You know more about the electromagnetic spectrum than you may think of. The image which shows, we have already seen the image. This image shows the, what does the image show? The image shows where you might encounter each portion of the electromagnetic spectrum in your day-to-day lives. In your day-to-day lives, we are using the various parts of the electromagnetic spectrum. Like for example, I'll give you the example. In this, you can understand where we are using the electromagnetic spectrum. In the So, the uses of electromagnetic spectrum, various regions of the electromagnetic spectrum. 1 minute. Radio waves. Your radio captures radio waves emitted by the radio station, bringing you your favorite tunes. So this is how you are using the part of the electromagnetic spectrum. Radio waves capture radio captures radio waves emitted by the radio station, bringing you favorite tunes. Radio waves are also emitted by stars and gases in space. They are also emitted by stars and gases in the space. Radio waves are also emitted by the stars and gases in the space. Microwaves. Microwave radiation, which we use for cooking in our house. Like you can cook your popcorns in just a few minutes. It is also used by astronomers to learn about the structure of nearby galaxies. Then, infrared rays. Night vision goggles pick up the infrared light emitted by our skin and objects with heat. In space, infrared lights helps us map the dust between stars. It helps us map the dust between the stars. This is the area where we are going to use the ultraviolet infrared rays. Then we have the visible region. Our eyes detect visible light. Fireflies, light bulbs and stars also emit visible light. Fireflies, light bulbs and stars, they all emit visible light, and our eye also detects visible light. Then the ultraviolet light. Ultraviolet radiation is emitted by the sun, and the reason skin tans and burns. That's the reason why because of the ultraviolet rays, our skin tans and it burns sometimes. Hot objects in space emit ultraviolet radiation as well. Then when we come to the next case is your X-rays. X-rays, the dentists use gamma rays. The dentists use X-rays to image your teeth, and airport securities use them to see through your bags. Hot gases in the universe also emit X-rays. So when you go to a dentist, any internal part of the body, if it needs to be diagnosed properly, where you are having a problem, you go for an X-ray. These X-rays also form a part of the electromagnetic spectrum. Then coming to the gamma rays, doctors use gamma rays imaging to see the inside of your body. The biggest gamma ray generator of all is the universe, which is the biggest gamma ray generator. So these are the areas where you're going to use the different types of electromagnetic spectrum, types of radiation which we use in the day-to-day lives. Then coming to the summary, I would like to summarize once again the definition of analytical instrumentation. We have dealt with the definition of analytical instrumentation. Analytical instrumentation is a branch of instrumentation which deals with identification of the composition of the sample of matter. It is a branch of instrumentation which deals with identification of the composition of sample of matter. Then basic blocks of analytical instrumentation. Various blocks of analytical instrumentation are chemical information source, the transducer, the signal conditioner, the display system. These are the different types of blocks of analytical instrumentation. That is chemical information source, then you have the transducer, then you have the signal conditioner, then we have the display system. All the four basic blocks we have. Then we have studied about spectroscopy. Spectroscopy, it is the study of interaction of matter with electromagnetic radiation. It is a study of interaction of matter with electromagnetic radiation. What are the types of spectroscopy? Basic types, we have emission spectroscopy and absorption spectroscopy. Emission spectroscopy, it is a study of absorbed radiation Emission spectroscopy is the study of the radiation emitted by the molecules, which can be studied to reveal the structure of the molecule, like photometry and fluorometry. Flame photometry it is also called as. So this is about the emission spectroscopy. Then the absorption spectroscopy, it is a study of absorbed radiation by the molecules in the form of spectra. Examples are UV, IR, NMR, colorimetry, and atomic absorption spectroscopy. So we have studied about the different types of spectroscopy. We have other types, that is called ultraviolet spectroscopy. They all come under absorption spectroscopy. Ultraviolet, infrared, NMR, and atomic absorption spectroscopy. Then we have studied about the electromagnetic spectrum, electromagnetic radiation. It is the radiation which travels with the speed of 3 into 10 power 10 centimeters per second. Is a type of energy that is transmitted. It is an energy that is transmitted through space. This radiation does not require a media for propagation and can readily travel through vacuum. Okay, these are some of the characteristics of electromagnetic spectrum. The characteristics of electromagnetic spectrum. Electromagnetic radiation may be considered as discrete packet of energy called photon. Discrete packet of energy called photon. So electromagnetic radiation is a type of energy that is transmitted through space. It is the type of energy that is transmitted through space with a speed of approximately 3 into 10 power 10 centimeters per second. This radiation does not require a media for propagation and can readily travel through vacuum. Electromagnetic radiation may be considered as the discrete packet of energy called photon. The most frequently asked questions from this topic may be you will be asked to define what is an analytical instrumentation, what are the different blocks of analytical instrumentation, the basic block diagram of analytical instrumentation. Then you will be asked to define what is spectroscopy, the types of spectroscopy, and define absorption and emission spectroscopy, and you will be asked to define the electromagnetic spectrum. So with this we are going to end our presentation today, where you have studied about analytical instrumentation, basic blocks of analytical instrumentation, the block diagram of analytical instrumentation, the spectroscopy, the types of spectroscopy,